going to go into chapter or lesson 10.6 today on factoring trinomials. The whole objective here today is to be able to take a quadratic trinomial, which is an x squared plus x plus a number type trinomial, and change it so that it equals the product of two binomials. And if that's called, obviously it's factoring because we're changing it from a trinomial to the product of two binomials. Okay. So we're going to work today that all have trinomials that have a leading coefficient of 1. So that means the trinomials will look like this: x squared plus bx plus c. Obviously, b and c are integers, okay, which means just numbers, positive or negative. Our job is going to be to find two new numbers, m and p, such that if we multiply m and p together, it equals c. And if we add m and p together, it equals b. Okay, so they have a sum of b and a product of c. Okay, what it will look like is that once we find out what that m and that p are, they become the second numbers in my two binomials, m and p. The x's are the first in my binomial. So what we're looking at right here is this trinomial is equal to the product of these two binomials when m plus p equals b and m times p equals c. All right, so that's the concept there. And I will go through several examples in the technique that I use to help keep myself organized and to put this all together. So we're going to work just with this today. A little heads up, could be a minus sign. This could be a minus sign. They could both be minus signs. So that's where some variation is going to come in, is the signs that are used here. But we do the process the same. Okay, we say that a trinomial is prime, or any polynomial is prime, when it cannot be factored. So if I come across one where I can't find an m and a p that will work, then I say that's a prime polynomial and it can't be factored using factoring techniques. Okay, let's get into factoring these quadratic trinomials. So here's our first one: x squared plus 7x plus 12. So again, we're going to look for two numbers that we can multiply together to get 12 and add together to get 7. Okay. The way I set it up is like this. I learned this a long time ago. My first column is going to be the x squared term. My last column is going to be the 12. And then when I combine these, I want to get a sum of 7x, which is the middle number. So the first number goes here, the last number goes here, and we're trying to get this as a result of these two columns. So what I'm going to put in the columns is, what do I got to multiply together to get x squared as an answer? Well, that's got to be x times x. X times x is x squared. All right. In this column, I'm looking for two numbers that give me a product of 12. Okay, so let's just say I pick 2 and 6 because I know 2 times 6 is 12. It could be 1 times 12, 2 times 6, 3 times 4. It's going to be one of those. Let's say I go with 2 and 6. Now, the next thing we want to do is multiply across. So x times 2, well, that's 2x, and x times 6, that's 6x. We're going to add these together. Does that give me a sum of 7x? Well, no, that adds up to 8x. So that means that's not the right combination. That's out. So we just put an x through that and we move on to the next one. All right, so we'll go again, x and x in the first column. Now in the second column, I'm going to go 3 and 4. I know 3 times 4 is 12. And now I want to see if when I multiply across, does this give me a sum of 7x, which is what we want the middle term to be. In this case, yes. And you guys might have guessed that on the first one. I just want to show you that you're not always right on your first guess. Okay, so what do we do with that now? Well, what we're saying is this trinomial x squared plus 7x plus 12 is going to equal the product of my binomials here. So when I go to put in my information, the two x's in this column, they go first in each spot. These two numbers go in the second positions of the trinomial, plus 3, plus 4. And by the way, to speak in terms of the first slide, this is m, this is p right now. That's the two numbers I've found. So what we're saying is x squared plus 7x plus 12 is equal to the binomial x plus 3 times the binomial x plus 4. And just to confirm that, let's multiply these two together. Well, how do we multiply two binomials together? FOIL. Firsts x times x, x squared. Outside, x times 4, 4x. Inside's 3 times x, 3x. Lasts 3 times 4, 12. Simplify it, we get x squared plus 7x plus 12. So this trinomial is equal to the product of these two binomials. Now, when we go to solve these, you'll see why we're doing this. For right now, we just have to be able to do it. We got to be able to write a trinomial as a product of two binomials. Okay, and that's kind of the pattern of what we're going to do. Let's do another one here. So x squared plus 8x plus 15. I think the chart is very helpful. So x squared is my first column, 15 is my last column, and we want to get a sum of 8x when I combine these two. So your first column, since it's just x squared, is just going to be x and x. Your second column is going to be two numbers that multiply together to give you 15. Well, you got two choices. 1 times 15, which you know doesn't add up to 8, and 3 times 5, which you do know adds up to 8. So obviously I'm going to choose the 3 and the 5. Now this is that MP that I showed you earlier, but this is how I do it. So multiply across, just to double check here. That's going to give me 5x. That's going to give me 3x. And when I add it together, I get 8x. Okay, so that's what we want right there. We want a sum of 8x. I get a sum of 8x. So that means I'm ready to load this in. So the first column, my x's go first, x and x. The second column numbers go second, 5 and 3. Now, it doesn't matter if I put a 3 here and a 5 here, or the way I have it, I'm going to get the same answer. Okay, so let's double check our work here. Let's FOIL this to see if we get this original. So first, x squared. Outers, 3x. Inside, 5x. Last, 15. Combine your like terms, x squared plus 8x plus 15. So this product of this binomial equals that trinomial. Okay, do another one. Now we got a little wrinkle here, right? We got a negative number here. Okay, so I want my first column to give me x squared, my last column to give me a positive 27, and the middle number now needs to be negative 12. Now you got to introduce a negative sign into the problem somehow to get a sum of negative 12, right? So you can't just go positive 3 and positive 9. Is 3 times 9 27? Well, sure it is, but multiply across 3x, 9x, 12x. We didn't want 12, we wanted negative 12. So what can I do to get this to become a negative 12? Well, not only is 3 times 9 27, but negative 3 times negative 9 is also positive 27. So when you get a negative number here and the last number is positive, these are going to be two negatives. It's the only way you can get a negative in the middle and a positive last is to go negative times a negative. That gives you the positive. So negative 3 times negative 9, that's positive 27. But now I have negative numbers involved that make my middle negative. Okay, so multiply across negative 3x, negative 9x, that's negative 12x. That's what I wanted, negative 12 right there. Okay, so now load it in your parentheses, right? I want this binomial product to equal this trinomial. So it's got to go x in the first spots, negative 3, negative 9 in the second positions. And again, it could have been negative 9 first, negative 3 last. Would not make a difference. Let's FOIL it. X squared, outers, negative 9x, inners, negative 3x, last, positive 27. Combine your like terms, x squared minus 12x plus 27. That's what we wanted. That's what this gives us. Okay. Another one. Same kind of deal. I got a positive here in my last position. That's a positive 16. So I know these numbers have to be the same side. Positive times positive or negative times negative, right? Since my middle number is negative, I know that they got to both be negative. So I want a negative 10x for a sum. Now I'm just going to throw this out there. I know it's wrong. Okay, I just want to show it to you. So if I try negative 4, that does give me positive 16. But the problem is I get negative 8 for my sum. So nope, no good. Go to the next. XX, and as you all may have guessed, negative 2 and negative 8. Doesn't matter if I go negative 8, negative 2, as long as I get these two guys, right? Multiply across, negative 2x, negative 8x. That's negative 10x. That's what we want, negative 10x in the middle. So this is the right combination right here. So I am going to put my x's first and these numbers second. -2, -8. Okay. If I FOIL this, I'm going to get this answer back. I better, right? So x times x, x squared, -8x for the outers, -2x for the inners, +16 at the end. Add like terms, x squared minus 10x plus 16. That's what we wanted. Okay. So you're really getting to see these very fast. The chart is great to set up just so you can see everything. And if you look at the FOIL process, this is firsts, right? This is outsides, this is insides, and this is lasts. So it's really the FOIL process right here. Okay, if you think about looking at your product versus what we did here. Okay, another one. Now, this time, the negative sign is last, and there's a positive here. So how are we going to get a -18 when we multiply? Well, one's got to be positive, one's got to be negative. Okay, and then we got to work it so that our middle is +3. So we'll go x and x, and let's go -2 and 9. -2 times 9 is -18. I know that. Okay, now multiply across. -2x, 9x is 7x. Is that what I wanted? No, we wanted 3. So this is not the right combination. What if I made this +2 and -9? Well, this would have made it -7x. So just switching the signs won't make a difference as to what we want. So let's go with 6 and -3. 6 times -3, -18. That's what we want. Multiply across. 6x, -3x, add them together, +3x. That's what we want right there. +3x. So let's put our information from our successful one in the parentheses. So the x's go first. We're going to go +6 -3, +6 -3. Okay. Go ahead and FOIL it. First, x squared, outers, -3x, inners, 6x, last, -18. That's what we want there. Combine our like terms, we get x squared plus 3x minus 18. Right there. Last example here. So I got a negative at the end, a positive in the middle. So when I set this up, I want a -5 from this product, and I want a +4 when I add them together. Okay, we'll go x. There's only one way to get 5 when you multiply two numbers together, and that's 1 times 5 in some variation. So I'm going to go 1 times -5. That equals -5. Multiply across. 1x, -5x. That's -4x. I wanted +4x. So that's not it. The only other variation we can get is -1 and +5, right? Negative times a positive, that's still -5. But now we multiply across, I get -1x plus 5x. That's +4x. That's what we wanted. So this is the right combination. So it's going to be x is first, -1 plus 5. Okay, FOIL it. X squared, outsides, 5x, insides, -1x, last, -5. Combine your like terms. That's our problem, right? This binomial times this binomial equals that trinomial. That's what we're trying to do. Okay. Looks like I got one more. I'll go through it quick with you. Now, a little tip here. This is negative. This is negative. This being negative is a big part of it because I know that I have to have positive negative combination here. And then I want that positive negative combination to give me a -5x. So 24's got a lot of combinations. 1 times 24, 2 times 12, 3 times 8, 4 times 6. So I went with -4 and +6 to start with. You guys get really good at this. You can see this isn't going to work, right? When you multiply across, you're going to get -4x and 6x. And when you add them, you get 2x. Well, we wanted -5x. Okay. How about -8 and 3? Well, -8 times +3 is -24. -8x, +3x, that gives you -5. That's what you want. So now load it in your parentheses. -8, +3, FOIL it. I'm just double checking here. You don't have to do this every time, but I like to know I'm right. So that's right. Okay. So by the way, this is the answer we want. We want to give them the two binomials we're multiplying together to get our answer. All right. Your homework is going to be set up for you. Okay. Make sure you work at it, write it out, make your chart, go through the process. By foiling it, you're just double checking things. All right, not a bad idea to make sure you have the answer right. Okay, I'll let you get to work.